Hello guys and welcome back to the channel. In this video I'm going to show you how I program the jig to hold down the part, and I'm going to show you how I program the vacuum pot for a Weeke BHC 350 pattern rail. Okay, I'm going to start with the jig, which is a 1-inch MDF bore, 25 inches in width, 12 inches in depth. Okay. Um, everything that you see here, I modeled in Fusion 360, so I didn't get the models from any other CAD/CAM package. Okay. So the first operation is drilling. Um, is a 14 millimeter V point boring bit to drill both holes. Okay. And then I use a 2D pocket. All right, to remove the material. Okay. And the last one is 2D pocket, and I'm just plunging into the holes and routing out. Okay. So I'm gonna select the setup MDF jig. I'm gonna right click and simulate. I'm gonna zoom in. I'm gonna slow down a bit. I'm gonna play it. And there's the first hole. Okay. I'll take the model. So you can see the hole right there. There's the second hole. Okay. And then it's gonna come in with 9 millimeter down cut, 2 flute down cut. Okay. It's gonna start removing the material. You see how it's leaving material here, but in reality, it didn't leave material. As you saw in the beginning of the video, it wasn't removing any material here, which is cutting air. So that operation was basically useless. All right. You see it's leaving material, but in reality, it wasn't. When I ran the part, um, it wasn't leaving any material there. Okay. So so it's routing. Okay. And then it's gonna retract and come to the first pocket right here and start cleaning up. Okay, it's gonna go back and forth, back and forth. See that? Um, but it wasn't really removing material in reality, so it was just cutting air. You see the last operation, which is let me go back here, slow it down a bit. I'm gonna play it. Okay, and it's gonna come back to the first pocket. It's gonna plunge into the hole and ride its way out. Okay, it's gonna plunge into the hole and rot its way out. See that? Okay. So let me show you the drilling operation. Right click, edit, and I got the spindle speed at 7,500 RPM, plunge feed rate 6 meters per minute. Okay. Next tab, geometry, and under geometry where it says hole faces, I selected both faces. Okay, this one and that one. All right. Next tab is the height. Um, where it says bottom height, right here. So my bottom reference is the edge. See it's highlighted in blue. Okay. And I have where it says drill tip through bottom. I have that checked. So I gotta make sure it's drilling through the material. Okay. So I'm gonna put it in front of you so you can see that right there. if I uncheck drill tip through bottom, see what happens. It's not drilling through, right? So make sure you check that, okay? And the cycle, this one I use. This is the one that works for the machine. The drilling rapid out, okay? I'm gonna click OK, and that's drilling. Let me show you the 2D pocket. Right click, edit. I'm using a 9mm 2 flute down cut from Amana. All right, and I had cutting feed rate 12 meters per minute, 14,000 RPM, and the geometry I got 4 chains. Okay, I got bottom face on this one and that one, and this right here is whole, right? Okay. Under heights, I didn't make any changes there. So under passes tab, I have a maximum step over of 5mm. Okay. I have a preserve order and both ways checked. Multiple depths. See the maximum roughing step down is 6mm. Okay. And under linking tab, I have a zigzag rem type, 2-degree angle. And I also have under linking where it says keep tool down, that's checked. You gotta make sure that's checked because you're gonna have a lot of retraction and you're gonna have a lot of macros in Woodwop. Okay. And this is my maximum stay down. It's set to 3,000mm. Okay. What else? I think that's it. I'm gonna click OK. So that's the first 2D pocket, and the second one, which is the last one. Okay. I'm gonna right click, edit, using the same end mill. Okay. I just want a little faster, 16,000 RPM. Same feed rate, 12 meters per minute. On the geometry, I have the bottom profile selected. Okay. And under heights. Okay, this is where see where it says clearance height. I selected the face. Okay. The retract height is that face. The feed height is gonna be the feed height is gonna be this bottom face right here. Okay. And the top height is gonna be the bottom face as well. The reason why is because I didn't want the machine. I didn't want the machine to start from all the way up here. I wanted the machine to start from here because I didn't have any material. All right, that's being removed. So basically, it was gonna cut air. All right, so that's why I changed my selection to face. So I'm gonna show you. So I selected that. See the clearance height? It's the top face of the bore. The retract face is the same face. Okay. The feed height. Okay. I selected the bottom face, and the top height is the bottom face right here. See the highlighting in blue? All right. And the bottom height, I have selected contours. Okay. Right here, this contour. All right. That's the bottom height. Okay. And the offset have a negative value, which means I'm going 2mm past the bottom of the face or the material. All right, so I just want to make sure I wanted to remove the rest of the material right here. So okay, you can increase this if you want. I didn't have any vacuum paths right here. All right, so I had them right here in this area. So this part right here was just it was just hanging in the air. So that's why I have a minus 2mm offset. To make sure I cut this material out. Okay, and I'm gonna click OK. Oh, sorry, I'm gonna go to passes and have a maximum step over of 8mm, multiple depths, 8mm. And I have used even step downs check, order by depth check. All right. If I can check this, I don't think it's gonna make any difference, but I'll just leave it how it is. On the linking tab, my rem type is plunge, and the rem clearance height is 1 millimeter. Okay. Let me click OK now. And let me simulate this 2D pocket. Right click simulate. Okay, someone's play it. See, it's going straight down into the hole. Okay. See that? Okay. Okay. That's the jig to hold the part. Okay. Now let's check out the program or the setup for the vacuum pot. So I have two setups. I have the top face, and I have the bottom. It's the bottom face. Okay. I'm gonna show you because I didn't. There's some features that I left out because this is actually my second time I machined this part. The first time I did it, um, the chamfer, there was a 1 millimeter chamfer on these edges, top and bottom. Somehow the chamfer was off. It was a little deeper, so maybe it had something to do with machine accuracy or the 90-degree whip bit was not calibrated properly. All right, so I didn't like how it came out. Also, somehow like a small chunk of wood just came off from this face. Um, Somehow the end mill just went there and machined that. I don't know how that happened, but let me show you that. Let me show you that program. But before, let me show you the vacuum pot, the 3D model vacuum pot. It's right here. You see it has a chamfer on the edges. Okay, rotate the model. See that? It has a chamfer on the holes too. Okay. Okay, you see that? See the four corners that chamfer as well. So let me show you the original program. Let me go back to this one right here. Okay. This is the program that I ran first. Okay. See that? So I had a 3D pocket. All right, not a 2D pocket because um, with the 3D pocket I was able to keep the tool down, which means it's gonna be one macro in Woodwop. All right, um, instead of like seven macros. Uh, but first I was using the 2D pocket, which is right here. This one is suppressed. On a right click, see suppress. I'm gonna unsuppress it. And I'm gonna right click and regenerate that tool path. Okay, you see that? See, it's retracting. It has so many retractions. All right. Okay. I'm gonna right click edit. I had keep tool down check. Okay. If I increase this, let's make this what 6,000 millimeters. I'm gonna click OK. I'm still gonna have the same retractions. See, it's not making any difference. Okay. So I didn't want to use the 2D pocket, so I went to 3D pocket. So I'm gonna right click, suppress that 2D pocket, and let's check out the 3D pocket. All right. See, you don't see any retractions. All right. So I'm gonna right click, edit, and okay. Spindle speed was 18,000 RPM. Cutting feed rate 10 meters per minute. Okay. Under geometry, where it says machining boundary, I got two chains selected, highlighting yellow. Okay. Heights, I'm gonna skip that. I didn't make any changes here. Under passes tab, this is where you have to you have to check where it says flat area detection. You make sure that's checked because this area where is flat, because this is a 3D pocket. Okay, and this is not really like 3D machining. This is the 2.5D machining, to be honest. So you gotta make sure that you have a flat area detection check, so it detects this flat face right here. Okay. Um, Under linking tab, the zigzag was the ramp type, ramping angle 2 degrees. The ramping clearance, it was a little high. It was 2.1 millimeters. It was just, I'll show you. Let me click OK. I'm gonna show you. I'm gonna put it on from you. You see how it started way up here? So it's basically cutting air for like a couple of seconds. All right. So I fixed that on my older program. Okay. So this is the first program that I ran on the machine. All right. I got pictures of how the part came out. So let me show you. Uh, you see that? That's the first. That's the first program. Top Faith. You see right here, it removes material. I don't know why it did that. You see the chamfer edges? They're not that accurate. I have another picture. See right there. Let me zoom in. So it took a big chunk of wood right here. You see the chamfer? See that? Is bigger, it's wider, it's deeper. Um, I don't know. Maybe I think it's an old machine anyway from 2004, so the machine is not really accurate. All right. This is the vacuum pot right here. Okay, this is all messed up. So that's why I started. I wanted to make vacuum pots for this machine. All right. It's right here. This is when I was removing from the clamping device right here. Um, okay, so but yeah, that's how it came out. You see it? Um, I didn't like how it came out, so I removed those features, the chamfer, okay, and I just did a square. I just want it to be square, okay. No chamfers on the part. All right. See right there. Okay. Let's go back to Fusion 360. Okay, so this is the first program. All right, so the 3D pocket, and there was a 2D pocket with a big hole, and they had the 2D contour to create these chamfers on the corners. Okay, so I'm gonna right click simulate. So you see the material here, but there's no material. It's just a part, so it doesn't really matter. Okay, so you see the material here. All right, so I'm gonna play it. See that? See how it's retracting? So I mean, look, the simulation looks good here. Um, but the part didn't. I mean, um, it's missing. It took a small chunk of wood right here as well. I don't know why. Okay, see it's retracting. So it's gonna have a lot of macros in Woodwop. You can keep the tool down if you want. I think I did that. I just forgot to save it. But you see here, it's just machining the corners. But somehow, like I show you on the picture, there's a chunk of wood right here missing, and this edge right here was really thin. Okay. Let me right click edit that 2D contour. I'm gonna go all the way down to passes, and right here where it says both ways. Now it's gonna keep the tool down. It's gonna go back and forth, back and forth. All right. So I'm gonna click OK. You see that? I'm gonna simulate. Right click simulate. See that? It's not retracting. This is the one that I used. I just forgot to save it. Okay. When I made the changes. Okay. That's a 2D contour, and then I use a 90-degree Vipit from Amana, tool number 45 726. Okay. I use this guy 2D contour to machine the chamfer edges. Okay. So I'm gonna simulate both 2D contours. Right click, simulate. All right. See, it looks nice and clean here, but in reality it didn't. Okay. All right, like I show you in the pictures. Okay, and then I did the holes here. I drilled the holes with a 3 millimeter broad point and then 5 millimeter broad point. Okay, and then I machined the hole in the big hole with a 9 millimeter flat end mill. And then I used a 2D contour. Okay, same as the first operation. And then I used the chamfer. Okay, on the edges. Okay, so this is the one that I ran first. Okay, so and then I made changes to the model. Let's go back to the final program. You see that square? I don't have the chamfer corners. I don't have the chamfer edges. Okay, the holes. This hole right here. First it was 5 millimeters, but it happened to be 6 millimeters, so I make this a little larger. And this one went from 3 millimeters to 5 millimeters. Okay. Um, Let me show you the original one right here. See the holes are a little smaller, and the edges are chamfer. Okay, so those are the changes that I made to the model. Okay. This small holes is supposed to have um, they're supposed to be threaded for the machine screw to go into. Um, so the vacuum pump wasn't really like screw onto the clamping device. It's loose. It's still usable. I tested it. I was getting good suction out of it. All right. So the original vacuum pump, the one that was on the machine, it had the hole. These 4 holes right here, the small ones, are threaded. Okay. All right. Maybe next time I'm just gonna make the holes bigger and get some inserts. All right, threaded inserts, and then just place them in here on each hole. Okay, and then I'll be able to screw this part onto the clamping device. Okay. All right. So let's go to this program right here, the vacuum pods. Okay. So setup one is the top. Okay. So we're using 3D Pocket. All right. Right click, simulate. You see the material here, but there is none. There's no material. Okay, so don't mind this right here. Okay. Um, I'm gonna show you. You can use. Let me go to the setup top. Um, setup top right here. Right click, edit. See where it says all the way down where it says fixture. You can select um the MDF board as a fixture if you want, and then you won't have this material here. Okay, see that? It's transparent. But if I do that, watch what happens. So on where it says model, I'm gonna click on the X. I'm just gonna select this guy right here. That's the model. I'm gonna check on the fixture, and I'm gonna select the MDF board right there. Okay. And my WCS is in the wrong place, so it has to be right here. So under stock point, origin, stock point right here, box point. You won't let me select the point here because I have the model selected, the 3D model of the vacuum pump. See these points right here, but I don't have it here. So under origin, stock point, I'm sorry, stock box point. I'm gonna check. I'm gonna click on that, and I think it's this right here. Yeah, selected point, select that. Okay, that's where WCS is gonna be on the stock. You see what happened? So see where it says stock height Z is 36 millimeters. That's the thickness of the vacuum pot. It's not really the thickness of the MDF board and the vacuum pot, right? So you're gonna have the wrong stock thickness, so you have to be careful when using on the fixture right here under model. So so it thinks that this is it's just taking the thickness of the vacuum pot as the Z height, okay, not the MDF bore, okay, jig, all right. Or you can do this if you want. Under mode, see right here, I'm gonna click on that to drop it down, and I'm gonna go down to where it says from solid, okay. In stock solid, it's gonna be that, right, the MDF bore and the vacuum pot, and now it's gonna give me the right Z height, which is 41.4 millimeters, okay. And I'm gonna check fixture. Okay, now you don't see the material here. You don't see that transparent box. I'm gonna click OK, and I'm gonna regenerate my toolpath. So I'm gonna hold down Shift on my keyboard, select the 3D pocket and the 2D pocket. Right click, generate. I'm gonna simulate, and watch what happens. You're not gonna see the material here, right here, where the groove is. So I'm gonna right click, simulate. See that? This is more realistic. Okay, more realistic, but you don't see the material here. But I mean that's fine. You know where the machine's gonna go. All right. You know that, okay? See that? And I'll select the 2D pocket, right click, simulate. See, there's no material here, okay? That's fine. You wanna have it like this, that's fine, but you wanna see the material being removed when you simulate the toolpath, just go back to the setup, right click, edit, and under stock, I'm gonna go to relative um, relative size box. I'm gonna go to that, and I'm gonna go to setup, and under model body, I have the vacuum pot selected. I'm gonna select the jig, all right, the MDF board, select that, and now I get the material here. See that transparent box? See that rectangle? Okay, sorry. Now I'm gonna go to stock, and I'm gonna have the right Z height, 41.4 millimeters. Okay. Okay. How do I get this? I'll show you, because the thickness of the MDF board is 1 inch, which is 25.4 millimeters. So I selected that edge. You go to the bottom of the screen right here. See where it says length, 25.40 millimeters. So that's 1 inch in millimeters, okay? 25.4. And let me see. So I'm gonna hit I on my keyboard to measure. I'm gonna select this edge there and this edge there, and that gives me 60 millimeters. Okay. So just gotta So 16 plus 25.4, that's going to give me 41.4 millimeters of Z height. So that's the thickness in the program, right, in Woodwop. So that's that's how you can check, all right, the Z height of the setup of the program. Okay, see that 60 millimeters plus the 25.4 thickness of the MDF board. All right, now close that. Okay, I'm gonna regenerate toolpath. So I'm gonna select 3D pocket, hold down Shift, the 2D pocket, right click, generate. Okay, and there it is. Okay, so let me simulate both toolpaths. So right click, simulate. I'm gonna put it on right from view. I'm sorry. Zoom out, slow down a bit. I'm gonna play. See, I decreased uh, the ramp clearance height. Okay, I went from 2.1 to half a millimeter. I'm gonna show you in a minute. Okay. So the 3D pocket, okay, and the 2D pocket. You notice I'm not going all the way through, right? Because the length of the flute is not really that long, okay. So that's why I only went down like halfway, um, 18 millimeters. Um, I think more than that. Let me show you. So let me go to the 2D pocket, right click, edit, and under heights. Okay, I have 19 millimeters. Okay, not 18. So I'm going 19 millimeters deep into the hole right there. Okay, where it says offset. All right. On the passes, um, I had a 4 millimeter roughing step down and a 4 millimeter step over on this one. Okay, I didn't want this thing to just pop right off. Okay, that's why I have a small value. Okay, of 4 millimeters. Okay, I have using step downs check, linking tab, uh, ramp type zigzag, um, ramping angle 2 degrees, and right here where it says ramp clearance height. Okay, I have half a millimeter. Okay, I didn't want to cut any air. All right, like the first program that I show you, um, and that's it for the 2D pocket. Um, and that's it for setup one or setup top. Okay, the next one is the bottom setup, the bottom program, it's the bottom face of the vacuum pot, and I use a 5 millimeter uh, bright point boring bit. I'm gonna right click, edit, and the spindle speed was 5,000 RPM. Crunch feed rate was 4 meters per minute. Under geometry, I selected 4 faces. Okay, right here where it says whole faces. All right, and under height tab. Okay, so the bottom height is gonna be the whole top right here. Is the bottom height. Okay, so I selected that. The offset is minus 19 millimeters, so that's how deep I was going. I wasn't. I think that's the depth of the holes, 19 millimeters. Okay, all right. Um, and that's it here for the heights tab under cycle. Drilling the cycle type is just drilling, wrap it out. All right. This is the one that works for the machine. Like I said before. All right. Click OK. I'm gonna simulate. Simulate. Yep. Slow it down a bit. I'm gonna play it. Okay. See, it's leaving some material there because this is 6 millimeters right there. Okay. This hole and this hole right there. All right. And then I use a 9 millimeter. Oops, sorry. 9 millimeter 2 flute down cut. Okay. To machine this hole right here. I'm gonna right click. Edit. 16,000 RPM, 7 meters per minute. Under geometry, I selected that top contour. On the height tab, I was going down where it says bottom height. I was just going down 19 millimeters. Okay, and under passes, um, it's the same as the first one. All right, step over is the same, 4 millimeters. Step down, 4 millimeters. Okay, linking on the linking tab, the rem type is the same. Everything's the same as the first one. Okay, and yeah, that's it for 2D pocket. All right, and the last one, oops, and the last one is a 2D pocket. I'm gonna right click. I was using a 3 millimeter 2 flute down cut. Okay, it's the same one that I use on the on setup one right here for the groove. Okay, same ML. Right click, edit. 12,000 RPM, 5 meters per minute. Okay, geometry. I selected the bottom contours. Okay, Under height tab, the bottom reference was the face of the hole right here. See this highlighted in blue. Okay. Under passes, I have a maximum step over 1.54 millimeters. It's supposed to be 1.5, but I'll just leave it like that. Preserve order is checked. Both ways is checked. On the linking tab, my rim tab was plunge. I was just plunging into the hole and route the rest of the material. Okay. Click OK. I'm gonna simulate this 2D pocket. Right click, simulate. I'm gonna slow it down a little bit more. It's gonna plunge into the hole. I'm gonna play it. See that? All the way down to the depth, which is 19 millimeters. And then it's gonna wrap out the rest of the material. See that? If I had a 6 millimeter broad point boring bit, I wouldn't be using the 2D pocket operation. Okay, it was just gonna be a drilling operation. Okay, but I didn't have one. All right, so I'm gonna close the simulation. Okay, guys. I'm gonna post process all these programs. So I'm gonna start with the jig. All right, so I'm gonna right click, post process, and this is the name of the program, right? MDF underscore jig. Okay, I'm gonna post it. I'm gonna go to Woodwop 5.0. That's the one that I have. I know it's really old. All right, I know some of you guys might have the new ones. All right, that's great. Okay, I wish you can have a copy of Woodwop 7. All right. I'm gonna open the file in Woodwop. We go to that folder, test programs. Right there, that's the program for the jig. Okay, so the 14 millimeter V point lower bit. Okay, okay, that's a 2D pocket to remove most of the material. Okay, that's the first one. That's the second one. And there's the other 2D pocket to remove some of the material that the first 2D pocket didn't remove that you saw on your simulation. But this one was just cutting air, like I said before. So I mean, next time I make this jig, I'm just gonna delete these macros. Okay, this one, this one. All right, and actually, it's more than that. I think there's like 8 macros. Yeah, like 8 macros. I would have to delete. Or I can just fix the program in Fusion 360. I'll just delete that 2D pocket. You know, this is the one that if plunge it into the hole and route route the rest of the material. Okay, see that? Okay, so if you want me to fix um, that pocket, you don't want to be cutting material. Let me go back to Fusion 360. I'm gonna show you how to do that. Okay, let's go back to this guy right here. Okay, under MDF jig setup, I'm gonna right click, edit, and under geometry, I'm gonna hold down Shift, select that contour to unselect it, and select this one right there. Okay, click OK. I'm gonna simulate that. Right click, simulate. Okay. See, it's leaving material, but in reality, it's not gonna leave this material. So there's nothing here. So the last operation, I was gonna come in, plunge into the hole, and route the material. But I'm gonna have a collision warning. So I'm gonna right click, simulate. I'm gonna play it, and right there, you see that? Because it thinks Fusion thinks that there's some material here, but it's not. You know, in reality, right? So you can just where it says stop on collision, just uncheck that. And you can just play it. See it? Let's go back to it. See? All right. So you don't have to worry about that collision warning. Just uncheck stop on collision right here if you want. Okay. And I'm gonna post process this program and open it up in Woodwop. So I want to post process. I'm gonna post it. Yes, I want to overwrite. I want to overwrite the following file. Yes. Let's go to Woodwop 5.0. I'm gonna open up new program and watch this. See that? You don't have that many routing macros. So you have the first one, 2D packet, the second one, a 2D packet, and you have this 2D packet right here where it plunges into the hole, all right, and then the last one, okay. See that? Now you're gonna have less macros, all right. You're not gonna be cutting air, all right. So that's how you fix that, okay. Let's go back to Fusion 360, and I'm gonna start posting the other programs to machine the vacuum pot. So I'm gonna post process the top uh, um, face program. So I'm gonna right click, and post process. The machine that I program at work doesn't have a tool changer, so I had to have two individual programs. All right. So the first program was just it was the groove, the 3D pocket with the 3mm flat end mill, and the second program is going to be the hole, right? The 2D pocket with a 9mm flat end mill. Okay, so I will have two programs in Woodwop. Okay, so I'll run this one right here with a 3mm flat end mill, and now I will swap tools. Okay, and then the second program is going to be a 9mm flat end mill. Okay, but if you have a tool changer, you can just post process the whole program, right? It's gonna be just one program. So I'm gonna right click, post process, and it's gonna say top. I'm gonna post it. I have a program called top already, so Kevin's gonna overwrite it. And I'm gonna go to Woodwop 5.0. I'm gonna open that program right here, right there. Okay, see that? That's the 3D pocket with the 3mm two flute down cut end mill, and this one is with the 9mm two flute down cut end mill. Okay, so that's one program. If you don't have a tool changer, you're gonna have two different programs, all right? Two individual programs. So let me go back to Fusion 360 and oops, sorry. Back to Fusion 360 and I'm gonna select a 3D pocket and right click, okay, and post process right here. And I'm gonna name this top, so I'm gonna type underscore, let's say groove, right? Or you can say 3D pocket. Okay, so I'm gonna type 3D pocket, so 3D underscore pocket. And under comment, you can change the comment, right? You can just delete words, right? Delete and 3/8 two flute compression bit, all right? You can delete that. So the comment, oops, pocket. Forgot about that. Okay. So this is the email that I'm using. So let's say you're just programming parts in the office. And you have another person running the machine. So you tell the person the machine doesn't have a tool changer. You just tell the person what email to use, right? You tell them, okay, you tell the operator when you open up Woodwop, just check the common macro in Woodwop. Just check it and just read what it says, and it's gonna tell you what email to use for that program. Okay, so in my case, I program the machine and I run the machine, so I don't have to type any comment here. So I know what email to use. But if you're in the office just programming the part and you have an operator running the machine, okay, and the machine doesn't have a tool changer, by writing a comment here, just this is how you let the operator know what emails to use, right? Okay. I'm gonna post it. That's one program. Now I'm gonna select the 2D packet, right click, I'm sorry, post process, and I'm gonna delete this right here, which says 1/8 2 flute down cut. I'm gonna delete that and the word end. Now does just telling the operator he's gonna be using he or she is gonna be using the 3/8 compression bit, right, or 2 flute or the down cut end mill or the 9mm flat end mill. Okay, that's the second program. So he or she will know what end mill to use for the second program. So let me post this. But let me type underscore, let's say 2D pocket. So underscore pocket. All right. So you know that's the second operation. Okay. I'm gonna post it. And let's go to Woodwop 5.0. File open. This is the first one right here, the first program, the 3D pocket. I'm gonna open it up, and it's gonna have one macro. Okay. All right. That's one program, and the top underscore 2D underscore pocket is the second program. And there's one macro. Okay. So you have two individual programs. If your machine doesn't have a tool changer, but when I posted this, when I posted this program, I posted this program as just one program. Okay, so I knew when to swap the emails. So, right, in my case, it will be just one program. But you know, but if you're just programming parts in the office and the machine doesn't have a tool changer, just you have to make individual programs, especially like the operator is like new to CNC and Woodwop. Okay. Let's go back to Fusion 360, and I'm gonna post the bottom face programs. Okay. Okay. Again, you can post this as one program, or you can post this as two programs if you want, or three programs. The first one's gonna be drilling. Second one's gonna be the 2D pocket with the 9mm flat end mill. Okay. And the last one's gonna be the two outer holes with the 3mm flat end mill. Okay, so you can have three individual programs if you want. You can have two if you want. You can let's um, select the drilling operation, the 2D pocket. Okay, I'm gonna hold down Shift. I'm gonna right click, post process. It's gonna say bottom, and I'm gonna type underscore. I can say 5mm. You know, it's actually 6mm. You know what? 5mm. Using the 5mm brad point underscore, and then I'm gonna write big hole, big underscore hole. So it's gonna do drilling with the 5mm brad point, and then it's gonna machine the hole, the big hole with the 9mm flat end mill. Okay, so that's one program. And under common, you have 3/8 says two compressions. It's supposed to say uh, two flute down cut. Oops, cut and 5mm brad point. Okay, so you're telling yourself what end mills are being used. Okay, or you're letting the operator know. Okay, what end mills to use for this program. Okay, so I'm gonna post it. So that's one program, and second one, I'm gonna right click, post process, and I'm gonna type underscore 6mm underscore hole, because those two holes are 6mm in diameter. All right. And it's gonna be 1/8 two flute down cut. Okay. Or you can type 3mm if you want. It's not mine sells this mil as 1/8, but it's not really 1/8 in diameter. It's actually 3mm because I checked it with my calipers. All right. So you can type 3mm if you want. All right. So I'm gonna post this program. And let's go to Woodwop 5.0. I'm gonna open the first program, which is this right here. Okay. Right here. Okay. I'm gonna open it up in Woodwop. Okay. It's gonna do the holes, right? 5mm holes, and then it's gonna route that big hole right there with the 9mm flat end mill. Okay, that's one program. Okay, and you have the common macro right here. See, you can also type you can type uh this is program 1. Okay, you let the operator know that this is the first program. Okay, you can save it. All right, you can save it right here if you want. Okay. Um, I'm gonna open up the second program, which is this right here. Okay, you can right here under the common macro, you can type this is program 2. Okay, all right. Okay, so I have two individual programs for the bottom face of the vacuum pot. I'm gonna go back to Fusion 360 and I'm gonna post process the bottom setup. So it's just gonna be one program, post process, and right here you just type you type 9mm two flute, okay, and 3mm two flute and mills. Okay, you can type that. All right, and you can also type 5mm broad point boring bit if you want. Okay, I'll just leave it like that, and then program name or numbers can be, it's gonna say bottom. All right, or you can type bottom phase underscore phase. All right, if you want. All right. So I'm gonna post this program. I'm gonna post it. I'm gonna go to WA 5.0, file, open. Uh, yeah, that's the program right there. I'm not gonna save this one. Okay, and this is just one program. Okay, see all the drilling and routing macros. Okay, okay. If you're experienced programmer and operator, you don't have to like myself. Like I'm programming and running the machine, so I can just make one program. So I know when to swap tools. Okay, so I know I'm gonna cancel the last two macros. All right, like that, and save it and run the program, and then swap tools. Right, go from the 9mm to a 3mm. All right, and then run the program. Okay, so I'm gonna select this guys right here. The last two macros are for the 3mm flat end mill. So I'm gonna cancel that macro and the four drilling macros. Okay, I'm gonna save it. All right, and the 3mm flat end mill is in the spindle. So I'm gonna run the program and finish the whole thing. Right. Okay, so this is how this is how I ran it on a machine like this. Okay, so let's go back to Fusion 360. And what else do I have to show you guys? Okay, I'll show you the original 3D model of the vacuum pot with the chamfer features. Okay, and I'll show you the first vacuum pot that I made. I'll also show you pictures how the part came out. I wasn't happy how the part came out. I think it has something to do with machine accuracy. It's an old machine anyway, so the chamfer wasn't that great. This holes right here were a little smaller. I have to make it a little bigger. Um, and I show you difference between 3D pocket and 2D pocket. Okay, why I use a 3D pocket, not a 2D pocket. Okay, I explained that to you guys. What else? Yeah, I think that's it. Um, okay, guys. I hope you guys learned something from this video, and I hope you guys enjoyed this video. Um, don't forget to like, comment, subscribe. Thanks for watching, guys. I'm gonna catch you on the next one. All right, peace.